Okay, so we have done a couple of lessons on this, and this is the third and final one on the SUVAT equations, and then we'll be moving on to a different topic in mechanics, but today we're going to be looking at this down here, which is gravitational acceleration G. Okay, so what we've looked at so far is things going across sideways, being sort of they're driving forwards, or they're being pushed forwards, or they're rolling forwards. And now we're going to be looking at vertical motion under gravity. So it's vertical motion, which is easier than diagonal motion. So if you imagine throwing a ball to someone, it's going to be going horizontal and vertical, but we are only considering things going straight up and straight down, which is makes things a little bit easier. We're going to be taking gravity to be 9.8 meters per second squared. You might use in physics something different, 9.81. Certain things might use 10, but we're going to be using 9.8, so get used to using that. Also, gravity has got the symbol G, lowercase g, and a lot of times you can see questions which just say G, and it might seem like a piece of algebra, something to work out, but that's just 9.8, so don't get confused by that. So let's have a look at this topic. So another little reminder of the equations of motion. We have we've got the four which are mentioned in specification, plus I've shown you a fifth one because why not, but everything you can do using the first four, and you need to be thinking of these today when we're looking at them, but we're not using this third one much because if we're talking about gravity, one of the things we always know is G is 9.8, so we're going to be using the ones with A inside them. Okay, so vertical motion under gravity. So gravity brings all things towards Earth, and on Earth it's 9.8, and it acts constantly on everything. So whether you drop a feather or an apple, gravity is acting the same. If it wasn't for air resistance, they would fall at the same time if you dropped a feather and dropped an apple. The video link down here, which I'll also put in the assignments tab, shows a hammer and a feather being dropped on the moon, and on the moon there is no air resistance, and so you can see this actually in effect. It's only a minute long clip, it's worth watching, I think. And so we are not going to be considering air resistance. Okay, it would greatly complicate things, and because this is the very beginning of mechanics, we're not looking to complicate things, we're looking to grasp the basics. Okay, and we've got to be careful about which direction we consider positive. Certain instances it makes sense to think of things going downwards as positive, and therefore gravity would be 9.8. And sometimes things going upwards could be positive, in which case gravity would be minus 9.8. It'll work out correct either way, but you just got to be consistent with within a question about what's positive, and in different questions, different things will make sense. For instance, if something starts up high and gets dropped down, it makes sense to think about positive as downwards, but if something is thrown up, then it makes sense to think about positive as upwards. So just be clear with a little diagram and which way your positive is, and make sure you get this sign right. And another thing is, when somebody says total time that an object is in motion, from the time it's projected to the time it hits the ground, it's called the time of flight, and the initial speed is called the speed of projection. So if you see those in questions, you'll know what they mean. So let's have a look at an example. So, book falls off top shelf of a bookcase. The shelf is 1.4 meters above a wooden floor. I'm not sure why the fact that it's wooden matters, but anyway. Find the time, find part A, the the time in which it takes the book to reach the floor, and part B, the speed at which the book strikes the floor. So first things first is draw a little diagram, pick which A is positive, and mark on what we know. So this is what a diagram should look like. Because something starts up high and gets dropped downwards and all the motion is downwards, it makes sense to think about positives going downwards, which means gravity is going to be 9.8. The distance from the top to the bottom is 1.4 meters. U, the initial speed, is 0 because it just falls off the bookshelf. And we're going to assume it's at rest on the bookshelf. And it's going to hit the floor with a final velocity of V. So again, solving all of these questions, just write down what you know, put question marks next to what you don't know, and see which formulas make sense to work it out. So we know that the distance is 1.4, gravity is 9.8, plus because we're saying positive directions down, initial speed is 0, and we're trying to find out the time, so T has got a question mark. So S, A, U, and T, no V, that means that we're going to use this formula, and S equals UT plus a half AT squared. Nicely, this disappears because 0 times whatever T is still 0. A half times 9.8 times T squared. And solve that, rearrange it, and you're going to get that T is the square root of 0.2857, which is 0.5345. It's got to be the positive one, because if T squared was equal to this, then T could be positive this or negative it, but because we're talking about time, it's got to be the positive version, but it's always wise to consider positive and negative when you've got T squared equals something, and give your answer to the appropriate degree of accuracy. 2 significant figures is normally standard, so 0.53 seconds, and just have a think about if it seems reasonable. And yeah, a book falling off a shelf, half a second, that seems reasonable. Okay, another example. Oops, sorry, part B. Part B is finding the speed at which it hits the floor. So now we know T as well, but we're not going to use that one because it's, first of all, it's something we worked out. So if we're wrong, then we're going to just compound our error and get the next thing wrong. And it's not exact either. We rounded that. All these other values are exact. Okay, so if you wanted to use one involving a formula involving T, which you could use V equals U plus AT. What you have to realize is that when you put in T, you have to go back to the point where it was a square root of something and it was exact. And also you would have to be pretty confident that you're right for your final answer to be right for V. But anyway, if we use this formula, V squared equals U squared plus 2AS, put in the numbers, 0, 9.8, 1.4, you're going to get that V is 5.2. And again, if V squared equals this, think about positive or negative. We are going in the positive direction, which is down. Our speed is going down, and so it's going to be the positive one. If for whatever reason it was going back up, then you'd pick the negative one. Okay. So, next question. Question 11. Ball is projected vertically upwards from point X, which is 7 meters above the ground, with speed 21 meters per second. Find A, the greatest height it reaches, and B, the time of flight. So, time of flight, remember from that terminology, it means how long is it in the air from when it's released from the hand until it hits the floor. So first step again is going to be draw a diagram. So our diagram is going to look a little bit like this. So it's starting 7 meters above the ground. Because we're throwing it upwards, it makes sense to pick your positive direction going upwards. It's going to reach some height we don't know, so we're going to have some distance which we can mark at S. And when it comes back down, it's going to not get to point X, it's going to go all the way to the ground, which is 7 meters below point X. And also, it looks like a curve, It looks like it's going across. We're not expecting it to move sideways as well. It's just going straight up and straight down. But our diagram looks like this, so we can see both the upward and the downward journey separately. We don't have to draw them on top of each other. So that's the only reason it seems to loop around. Okay, so first thing, the height above the ground it reaches and the time of flight. So let's write down what we know. So we know initial velocity is 21. Final velocity is 0. We're going to say it's 0 because when it reaches the top, that is when gravity has overwhelmed the initial velocity and it's at 0 and it's neither going up nor down and it's about to go down. Gravity is minus 9.8 now because it is acting in the opposite direction that we've picked as positive, and the distance is what we're looking for. So S equals, we don't know, and so we've got V squared equals U squared plus 2AS. If we put in the numbers, we're going to get 22.5. That is just from X up to the top. If you then add 7, you're going to get the greatest height it's reached. Now, what you've got to be careful about is you can't just label your diagram as from the floor all the way to the top as S, because where it's initially moving from, where we know other information, the speed is from X. And so if you pick S to be from the floor all the way to the top, then you do not know the initial speed because it never started from here. So if you picked this from the bottom to the top to be S, and then you still picked U to be 21, you will get the wrong answer. So you've got to think about where you know certain information from and start everything from there. Another thing is 29.5. They round it to two significant figures to get 30. Leaving it as 29.5 is probably what I would do. It seems more sensible. And if we want to use that value somewhere else, it's going to be more accurate, and you're not going to lose marks for being more accurate in this sort of instance. Okay, so part B, the time of flight. So part B, time of flight, we know that the original speed is 21. The gravity, the acceleration due to gravity is minus 9.8 times what we're looking for. Now S equals minus 7. Because the flight is the total time the ball is in the air, the ball is going to stop moving at minus 7. So this minus 7 is the fact that it's going to go up where our displacement is going to be another 22.5. It's going to go down and down and down and down, and it's going to end up at minus 7. We're picking this point here to be 0, which means the final displacement, the end point, is going to be minus 7. That's probably the trickiest part to this question. Once you've realized that, you put the numbers in, and what you're going to do is you're going to get a quadratic equation. Now, you could just put it in a quadratic formula, but use your calculator. If you've used your calculator to do that, it's going to get you the answer and much easier. Let me remind you which buttons to press. So if you turn it on, press menu, go down until you get to option A, equation function. Select polynomial, degree 2, fill in the different coefficients, so 4.9, minus 21, and minus 7, and it'll tell you your two answers. Now, the time of flight has got to be something positive, so it's got to be this 4.5. It can't be this minus 3.3. That minus 0.3 is assuming that if it tracks back from where it started, where it would be at minus 7 here. Now, spotting this minus 7, like I said, is the trickiest part. If you didn't spot that, what else could you do? We could still do it in a couple of steps, which Might be not as sophisticated, but would be a bit easier and get us the answer. So what you could do is you could think, how long does it take me to get from X up to the top? And then separate journey, how long does it take to get from the top to the bottom? So what you'd have to do for that situation is, from X to the top, we know that S is going to be 22.5, U is going to be 21, and we've got our gravity. If you use this formula, you would get a positive value for T. And then the second part of the journey, you'll be starting off as U as being 0. Okay, we know that U is 0. We would now think that gravity is 9.8 if we're thinking about this going down. Our distance would be 29.5. And if you put those two parts in, solve those separately, and add them together, you should still get 4.6 seconds. But it's more work. But I think it's better to do more work that you're confident with than trying to do something sophisticated but getting it wrong. Because it's very easy to say that this is -7 when we can see that it is, and it's the right one to use, but I don't know how many people would be confident putting that in initially. So there's nothing wrong with thinking things as two separate parts of the journey and adding them up. Okay, so look at another example. So particles projected vertically upwards from point O with speed u, so generic terms. The greatest height is 62.5. We've got to find the value of u, and the total time the particle is 50 meters or more above O. So let's draw a little diagram. Right, so we've got, first of all, this point O. We're not saying it's the ground, because the way the question's worded, we don't really care about the ground. We're just thinking about speed and how far it is above this 50. So marking on 50, it's the distance between O and up here. It's going higher than 50, though. It's going up to 62.5, and it's going to go back down. Because the initial this direction is going upwards, we're going to pick that to be the positive direction. And then this diagram represents this situation. So if we figure out what we know, what we're looking for, and put it into the appropriate formulas. So V is 0. That's the final velocity, because we are thinking about how long it takes to, the initial speed. So if we think about just the first half of the journey, then when it gets to the top, the final velocity will be 0. How far it will have traveled will be 62.5. Gravity is -9.8 because it's acting downwards, and we pick positive to be upwards. If we put those figures into our equation, we can get that the answer is 35. So we didn't use the entire journey there. We just picked a certain point of it where we knew most information, because we don't know what the velocity is at any point really, except for at the top there. We know it's 0 because we weren't given u initially, but we know that's going to be 0. We knew the distance, we knew the gravity, so that made sense to be the sensible place to pick. So this is an exact value. If it was something to round, you'd round it to a couple of significant figures. And then the next part is we've got to figure out the time taken, the time above 50. So let's have a look at this. We've got S is 50. Okay, so we've picked S to be 50 because that is the critical distance we're looking at. Okay, this U is 35. That is what it's released at. And gravity is -9.8. So what we're doing here is we're saying how long, if we release it at 35, how long will it take to get to 50 meters? So we're not figuring out at the moment how long it'll be above. That comes later. We're going from here up to 50. And if you solve it, it's a quadratic, and you get two positive solutions. At this point, it says use quadratic formula, use your calculator. You get these two values, and they're both positive, and so you think which one's right, which one's wrong. It's perhaps a little bit difficult. Now, they're both right. You're going to get one which is 5 point something and one which is 1 point something. Now, if we think about it logically, we're starting here at 35, and then it'll get to the 50 meter mark here after 1.9 seconds, and also here at 5.2 seconds. And so they're both correct. And the amount of time it's above 50 meters, well, all the way from 1.9 seconds all the way to 5.2 seconds. So if you subtract those two values, that is how far it is above this line. Now again, this is a little bit tricky how to get this started. Once you get it started, it's easy. But all you've got to do is you've just got to put down what you know and try to figure out different things. And you might not get it exactly this way. There are other ways of doing this. You could think to yourself, how far does it take to get up to here? How far does it take to get up to here? You could split it out into 4 separate little parts of the journey and subtract the appropriate ones. You could do it like this and set it into 2 different sections of the journey from here and to here. But whichever way you do it, you should always end up with the right answer. But the diagram makes things much easier, and just be consistent with what values you are picking. So make sure that if U is something, that you are actually starting from here. Because if you're deciding to start from here and looking at the downward part of the journey, then U is actually 0 at this point, because that's where we're starting from. Okay, one more example, and then you'll have a go at some of these yourself. So, last example, a ball A falls vertically from rest from the top of a 63-meter tower. At the same time as A begins to fall, another ball B is projected vertically upwards from the bottom of the tower with speed 21 meters per second. The balls collide. Find the distance of the point where the balls collide from the bottom of the tower. Right, diagram needed. And our diagram looks a bit like this. Here's our tower, 63 meters. A's at the top, is being dropped down. B's at the bottom, being projected upwards. And they're going to meet at some point. We don't know what that is. We've got 2 separate distances. We've got this distance and that distance. We don't know what they are, but we know they're going to add up to 63. A's moving downwards, B's moving upwards. We've got to be careful with which way is positive. So it's because 2 things are going in opposite directions. There's no obvious way of doing it. If you just pick one to be positive and the other one to be negative, or the other way around, it'll still work out. So in this case, we're going to pick for gravity to be positive, acting downwards. And so just consider A and B separately. We know that the initial velocity for A is 0. We know that gravity is 9.8, not much else. And we can put our information into S equals ut equals half at squared, but we are going to get S and T both as unknowns. We can do the same thing for B though. So now the initial speed is 21. The gravity is minus 9.8 because we've got to be consistent. We're having positive direction as down. And if we put that information in, we're going to get S2 is equal to 21t minus 4.9t squared. The other piece of information we know is that S1 plus S2 equals 63. So, hopefully you can spot what we're meant to do from here. I'll give you a moment to have a think about it. Pause it if you want a bit longer, but otherwise I'll tell you how to do it. So instead of S1, we could write 4.9t squared. Instead of S2, we could write 21t minus 4.9t squared. And then if we put them added together, making 63, then all we've got in that equation is t. We could figure out t, which is not what we're looking for, but it's enough then to find out what we're looking for. So if we substitute in, instead of S1, 4.9t squared, and instead of S2, 21t minus 4.9t squared, add them together equals 63. It seems like it's a bit complicated quadratic, but the 4.9t squared cancel, and we're left with 21t equals 63, which means that t equals 3, they're going to collide after 3 seconds. This dropping down and this being projected up, after 3 seconds they collide. And then if you figure out distance S2, now the reason we're looking for distance S2 is because the question is asking how far from the bottom of the tower. So put back into 21t minus 4.9t squared, t equaling 3, you're going to get 18.9, which you can leave that as 18.9, or you can round it to significant figures, depends what the question's asking for, but if you can, I think it's best to put an accurate answer. And you're going to get how far it collides from the bottom of the tower. Now, I think those examples, the first two were pretty easy. The second two were more difficult. And the reason the second two were more difficult was just knowing where to start and what you can call things. Okay, so just a diagram is really important, and just think, if I'm going to use all these numbers in an equation, they've got to all be considered from the same sort of starting point. So if my initial speed is from a certain position, then distance should be taken from that position. If my initial speed is somewhere else, then distance should be taken somewhere else. Pick a positive direction. You don't always have to get things in one step. It can take a couple of steps. You can split journeys into 2 separate parts, perhaps upwards and downwards, or up to a certain point, and then from that certain point up to the top. If you just take it step by step, write down everything you know, draw a diagram, and be just willing to try a couple of different things, then you should get the answer. So I want you to have a go at this exercise, which is attached. Some will be straightforward, some you might find difficult, but have a go, and if you find anything difficult, ask, okay? And I'm more than happy to do sort of video solutions for questions that people found difficult, but you've got to take the first step and ask for that. Okay, that's everything for today. If you've got any problems, then just ask me, just email or on the chat, and I'll do my best to resolve them as quickly as possible.